All right, this video here is focusing only upon range. So you may have seen a video with the same exact picture of these functions, but that video was about domain. Here I'm going to be using the same exact functions, but I'm going to explain to you the concept of range. All right, so we're not going to be focusing on domain. So you're not having a déjà vu. These functions you just saw in a previous video on domain, but we're just going to look at the graphs and state the range. So I just want to remind you again that whenever you're asked to find the range, you're giving all the possible outputs or all the possible y values the function can produce. This function here can produce the number 24 if I put in an x value of 10. So we would say that 24 is in the range of that function because it can produce it. There does exist an x value, in this case 10, to put into the function to get an output of 24. This function also has an output of 0. The x value you have to put in would be a negative 2. 2 times negative 2 is negative 4, plus 4 is 0. So we would say that 0 is in the range of the first function because it can produce it. Now, the range can be infinite, which means that function could produce a large number of values. Sometimes it could be an infinite amount of values. So the easiest way to do this would be to look at the graph for each of these. So in the previous video, we were thinking left and right, east and west. As far as range, we're only going to be thinking vertically now, up and down. So let's look at all of these graphs and state the range. All right, so range. Same graph as the previous video, but we're now focusing up and down. This graph goes down forever, it goes up forever. It reaches the ceiling or reaches the heavens, and it goes all the way down below. So we would say the range is from negative infinity to infinity. And yeah, the domain was the same thing. Now in pre-calculus, there are 4 different infinities. There's left and right. There's negative infinity. And positive infinity is to the right. And there is down and up forever. Okay? So I want you all to keep that in mind, that even though we're using the symbol infinity here for domain and we're using negative infinity for range, those are 2 different directions of infinity. This infinity is down forever, and this infinity here is up forever. Over here, this infinity is to the right forever. If you could sort those 2 things, if you could sort those things out, it's going to make life a lot easier for you. Domain is left and right forever, and in range here, in this case, it's down forever and up forever. Okay? So you're using infinity in both contexts, but the 2 infinities are different directions of infinity. All right, this guy here, our sad face graph. So our range, the lowest it goes, notice it goes down forever. So it starts at negative infinity. We're going to scan the graph from bottom to top. It doesn't have a bottom, it has no beginning. But it does have an end. It peaks at 4. Since it touches 4, we put a bracket on the 4 because it includes the 4. This guy here. So the plus 4 actually moves the graph to the left 4 units. Starts here and goes this way. This pink graph, that's the parent function. So square root of x looks like that, but putting plus 4 on the inside moves it to the left. Okay. Now the domain starts at negative 4, but now we're looking at the range. Okay. The lowest it goes is this point here, and on the y-axis that is at 0. So it starts at 0, And it starts to, even though it's climbing very, very slowly, eventually this thing will keep getting bigger and bigger and bigger, taller, taller, taller. It has no end. So it goes to infinity. Okay? Looking at this graph here, the lowest it goes here is 0. Here it goes down to 0, so it's a tie. So whenever it's a tie, they're at the same level there. It's just a tie. It starts at 0, and it has a peak here at 5. So it goes up to 5, and it actually touches 5, so we put a bracket there. Okay, so once again, range is, you think, bottom to top. Okay, on the left function there, once again, I did it very quickly. The x value is -4, but the y value there is at 0. Okay, so this domain here, or this range, it doesn't have a beginning, but it does have an end, right? This one here does have a beginning here at 0, but it has no end. It has no ceiling. It goes up forever, okay? And this function here on the right, this semicircle here, it has a beginning at 0, and it does have an end. So these functions are very unpredictable. You're just going to have to look at the graph and scan it from bottom to top. This guy here, let's just skip that one. The rational functions here, you can skip that one for now. I don't think it's in the summer homework anyway, so let's skip it. It's not in the summer homework for range. It is for domain. That's a whole different issue. So range, it's not in there. The cubic function here, first of all, the parent function looks like this. The -2, all that does is it moves the graph down 2 units. Because it affects the output, it moves it down. Goes like that, that. All right. Now range, let's scan it from bottom to top. How low does it go? Well, this thing goes to the left forever, but it's also going down forever. So the range, it doesn't have a beginning on the bottom, and then notice as it's moving to the right, it's also getting taller. It's going up, 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 up forever, so it's going to go up forever there, okay? And you never put brackets on infinity, okay? This means you're including infinity here in the brackets. Remember, when you use bracket, you're saying you're actually getting to that point, and there is no getting to infinity. Okay, only Buzz Lightyear can get to infinity and beyond. In math, though, you don't ever get to infinity, so you can never include it with brackets, all right? So never, ever write that. And I think that will do it for range. Let's go back to original functions. That one we skipped. Got it, got it, got it, got it, got it. All right. So I try to give you a variety of finding the range of a linear function, a quadratic, a cubic, a square root, an uglier square root, and a cube root function here. Rational functions are not that important in regards to range at this point.